This is an AQA GCSE chemistry question. It's from the Trilogy 2019 paper, and it is a higher question. I'm going to recommend you pause the question initially, have a go at it, and then review. So here's part A, part B, part C, part D, and part E, a total of 12 marks available. So let's look at part A. Copper is extracted from low-grade ores by phytomining. Describe this process. So it is important that you get a handle on phytomining, certainly more so in terms of the detail than bioleaching. You grow plants on a low-grade ore. Remember, a low-grade ore contains less copper. But what we then do is we burn the plants to produce an ash. Now, what's actually happened here is as the plants have grown, they have taken in the copper from the low-grade ore. So it's been concentrated inside them. When you burn the ash, you've got a much higher concentration of copper. That then allows us to dissolve that ash in sulfuric acid. We make copper sulfate, and the copper sulfate can then be broken down into certainly the copper, going to extract the copper from it using electrolysis. The alternative is displacement with scrap iron. You're hopefully familiar with both of those methods. For part B, we have another method of extracting copper from low-grade ores is bioleaching. We have been given some data, and you are going to calculate the number of moles of copper that can be produced from 1 dm cubed of the 0.319 grams per decimeter cubed solution. So we have got a mass of 0.319 grams per decimeter cubed. So in 1 decimeter cubed, we have 0.319 grams. And we can also find the MR of copper sulfate, 63.5. There's a 32 and there's 4 16ths, giving us 159.5. So if I have my 0.319 mass and my MR of 159.5, I can do N is M over MR. I get to 0.002 moles. On to part C, copper used as a catalyst. The diagram shows reaction profiles for a reaction with and without a catalyst. Now you've got to read the question carefully here. How do the reaction profiles show that using a catalyst does not affect the overall energy change for the reaction? Well, if we go through, both reactions profiles show the activation energy. They both do, but that doesn't tell us anything about the overall energy change, which is what energy the reactants hold compared to what energy the products hold. Both of the reactions show exothermic reactions. They do, but that doesn't mean the overall energy change is the same. The activation energy is much lower with the catalyzed reaction. Again, that's true, but that has no bearing on the overall energy change. The key, and I've already alluded to this, is that the reactants have a particular amount of energy, the products have a particular amount of energy, and adding a catalyst doesn't change that. So the overall energy change from reactants to products is the same, whether a catalyst is used or not. On to part D. Copper is a catalyst in a reaction to produce ethanol from carbon dioxide. Ethanol is used as a fuel. Suggest why ethanol from carbon dioxide is sustainable. Well, remember that carbon dioxide going into the atmosphere contributes to global warming. If instead we're taking that carbon dioxide and making ethanol, then it's the same CO2 that will be released when the ethanol is burned. There is no new carbon dioxide going into the atmosphere. And finally, part E, chemistry plays an important role in sustainable development. This is a definition question. What is sustainable development? In sustainable development, we meet the needs of the current generation without compromising the needs of future generations. A definition that's very important to learn. And that takes us to the end of the question.